Next, you're going to look at KCSE 2001, and this was the questions. It was saying the figure below shows two spheres made of wax, each of mass 0.01 kg, held in a liquid by strings A and B. So we have a cylinder here, and then you have two here we have this is B, this is A. That's wax. Then this is definitely the liquid, and this is now the wax. If the upthrust on each sphere is 1.05 newtons, determine the tension in each string. Determine the tension in each string. So that was the question. We have two spheres that are made up of wax that are held by strings A and B, and you're supposed to get the tension in each string, that is string A and string B. So this is string A, the string B. The string B holds the sphere B. Then now string A is attached to B and holds now A. The string A holds now this wax. So, and you're supposed to take G as 10 grams per meter squared. So that is accelerations due to gravity. Now, we have here, we know they're supposed these things, because wax, these two series of wax, if there are no strings, they would actually float on water. So that means we can say there is tension in these two strings. So we can write here tension. Let's start with A. Tension in A is given by the upthrust minus the weight of that sphere. Because we have, let's magnify that's a wax, so we have that tension, it won't go away, but then we have the weight downwards, that's the weight of this sphere. So to get now the tension is the upthrust, the force upward, the force that is going upward, and then we have the tension. So the resultant is equals the tension of that string. So therefore we have the upthrust, and we are told the figure below shows two spheres made of wax, each of mass 0.02 kgs and held by two strings A and B. If the upthrust on each sphere is 1.05 newtons, determine the tension in each string. Therefore, the upthrust here is 1.05. We subtract now the weight. We want to get the tension in A. So we have 1.05 as upthrust newtons. We subtract the weight downward to get the resultant force, which is now the tension. So the weight is 0.1 kg. We need to multiply this by 10 because we are told G is equals 10. So we multiply by 10 to get newtons. We get is 1 Newton. So we need to subtract here 1.0 newtons. To get the tension is equals to 0.05 Newton. That's the tension. The other questions is the tension in B. The tension in B. The tension in B, which will be equal to tension in A plus tension in B. Now the up thrust in each case, which is 0.05 plus 0.05 is equals to 0.1 newtons. Example 2, it says this was KCSE 2002. It says a block of glass of mass is 250 grams floats in mercury. What volume of glass lies under water? Lies under the water surface. Under the water surface of mercury. And you are given density of mercury is 13,600 kilogram per meter cubic. That's the question that we're going to look at. A block of glass of mass 250 grams floats in mercury. What volume of glass lies under the surface of mercury? Density of mercury is that. So in that question, let me try to sketch that question here so that we see how we can work it out. We're told we have the glass block here. So this is a glass block. This is now the mercury. We are supposed to determine the volume of the glass of this block of the glass block that lies below the mercury. And we have the mass of this glass block as 250. Now, in this question, we must remember that a floating object, if the glass block is floating, then you can say a floating object displaces its own weight. A floating object displaces its own weight. That should be the guiding principle, because the glass block is floating in mercury. Therefore, a floating object displaces its own weight. So when the glass block is floating, it must displace its own weight, and the weight of the glass block is 250 grams. So weight of the block is equals to 250 grams. We divide by 1000 to make it into kg. Then we multiply by 10 to make them newtons. So that goes. So we can say it's equals to 0.25 newtons. So the weight of the block is 0.25 newtons. And we can say that the weight of the mercury displaced is equals to 0.5 newtons. So weight of mercury displaced is equals to 0.25 newtons because a floating object displaces its own weight. So if this is the weight of the mercury displaced, and then we have the we have the density of the mercury. We can get the mass of the mercury displaced is equals to 0.025 kg, and we have its density. The density is 13,600 kilogram per meter cubic. What we need to know is the volume of the mercury displaced. So we are going to have volume is equals to mass over density, and we have the mass as 0.0. Help me divide this, please. Volume is equals to mass over density, and mass is 0.025 divided by density is 13,600. So 0.00 1, 2, 3, 4, 5 184 meter cubic. So we are not told to give the volume in either meters or centimeter cubic, but that is the volume in meter cubic. If you want to give it into centimeter cubic, we multiply by 1 million, so to be 1, 2, 3, 4, 5, 6, 1.84 centimeter cubic, or 1.84 times 10 to the power negative 5 meter cubic. So that's the volume of the glass block that is below the mercury level. And I've said we can only answer these questions by the law of rotations, which says a floating object displaces its own weight. Therefore, and because we have the weight of the glass block, we have the mass of the glass block, we can get mass in kgs, and consequently we can get the weight. And the weight is 0.025. Then that means that should be the weight of the mercury that is displaced. And after getting the weight of the mercury displaced, we can get the mass by dividing by 10. And after getting the mass and you have the density, we can get the volume, which we have the mass here in kg divided by volume in meter density here to get 1.84 centimeter cubic. So that is the mass of the volume of the glass block below the mercury.